In this lecture, we'll be seeing goal programming. Goal programming is one of the technique to handle multi-objective programming problems. Multi-objective programming problems and LPPs, which we have seen earlier, they look similar only for one difference, that is in multi-objective programming problem, there are multiple objectives, and the linear programming problems, which we have seen, has only one objective, maximize or minimize. In multi-objective programming problems, objectives are seen sometimes as goals. The difference between goals and objective is that objective means in LPP you have seen it is either maximum or minimum. You don't know the value of the maximum or minimum. You don't know the value. Whereas as far as goal is concerned, you know the value. Okay, you know the target you have to reach to. Okay, you may exceed the target or you may fall little short of the target. That target is called as a goal. You know the value when you talk of goals, and when you talk of objective, it is either maximum or minimum. So, in this lecture, we'll be seeing how to formulate the goal programming problem, right? We'll be taking two problems for formulation, and one problem will be solving the solution of the formulation is done by modified simplex method. There are little modifications. It is a simplex method only. There are little modifications which you have to observe. If you understand those modifications, then it is not much different than the simplex method. Formulation is a little bit crucial, important, right? So first problem here we see the goal programming. So there are two products. There are two products, A and B, to be produced using three chemicals. Refer following details. Right? So here we have chemicals. All right. And amount required for for 1 unit of A, uh, for B, and here is the availability. All right. So there are three chemicals, 1, 2, and 3. All right. So A requires 3 unit of chemical 1, and um, 5 units of chemical 2, and 1 unit of chemical 3. Right. Whereas B require 4 units of chemical 1, 6 units of chemical 2, and nothing right now is talked about. Nothing right now is talked about chemical 3. Whereas as far as availabilities are concerned, chemical 1 is available in quantity 50. Right here, as far as product B is concerned, it requires 4 units of chemical 1 and 6 units of chemical 2. As nothing is mentioned about chemical 3, we'll assume that B doesn't require any unit of chemical 3. Now, availability of chemical 1 is 50 in a certain period, 60 units of chemical 2 are available, and about chemical 3 nothing is mentioned right now. And profit per unit for product A is rupees 70 and product B is rupees 80, right? And there are few things additionally being mentioned, and those are: profit is to be kept above rupees 100. Is to be kept above rupees 800. This is first thing. And second thing which is mentioned is quantity of item 3. Quantity of item 3, that is chemical 3, is to be ordered should be less than or equal to 8. All right, less than or equal to 8. And third, because of certain limitation, total production is to be minimized to 8. Means when I say 8, it means that it can be less than 8 also. All right. So this problem sounds more or less similar to LPP, but we are seeing that when if we handle it as LPP, we will have immediately our objective as maximize profit. But here we are seeing that the production is to be minimized. Then it is a little bit of conflicting situation. Production is to be minimized and profit is to be maximized. Okay, so this thing, there are two things in when we look at the problem to be handled by goal programming. One are called as rigid constraints, and another which look like constraint but not, they are not actually constraint, they are that way targets, those are called as goals. So there are two things. All right, I'll be taking another page. So there are two things, as I said: rigid constraints and targets. Okay, but before we look more about it, in the style of our formulation, we'll be taking let x1 be units of A and x2 be units of B to be produced. Right? So now when we will be formulating the problem in regular style, we may formulate it like this: maximize profit, maximize z equal to 70x1 plus 80x2, subject to, this is not what you have to do when you will be formulating the problem by goal programming. I'm just explaining you how the LPP of this problem would be. Okay. So this will be the objective function, and then your first constraint will be due to the requirement of availability of chemical 1, and this is it is required to be 3x1 plus 4x2, and available quantity of chemical 1 is 50. So this is to be less than equal to 50, and another chemical will be 5x1 plus 6x2 less than equal to 60. Okay. And then about chemical 3, the it is required by product A, it is not required by product B. And about availability, there is a mention here that quantity of item 3 to be ordered should be less than equal to 8. Okay, so I can write, if I happen to formulate this as an LPP, okay, here I write LPP formulation, so that you don't treat this as a goal programming formulation, right? So X1 will be, um, sorry, X1, 1 into X1 will be less than equal to 8. Okay. And this profit is already considered, as you are seeing. This profit is already considered 70x1 plus 80x2. The first constraint 3x1 plus 4x2 less than equal to 50. Second constraint 5x1 plus 6x2 less than equal to 60. And here, though the availability is not given, it is given here. So I have wrote the constraint 1 into x1 will be less than equal to 8, and there sounds to be some constraint here. Profit is to be kept above 800. Okay. In LPP, that is really not needed, but in goal programming, we have to target, we have to give the target of something called as our objectives, right? But this may be misunderstood as the constraint by LPP programmers, right? And it will get written as 70x1 plus 80x2 will have to be greater than equal to 800. All right. And total production is to be minimized to 8, and that also will be written as x1 plus x2. This is the number of units of product A and number of units of product B, that sum of the production has to be kept less than equal to 8. And lastly, you will be writing x1 comma x2 greater than equal to 0. This is LPP formulation of it will be. But what this will do, this will help you finding the value of units of product A and product B to be produced so as to maximize the profit. But when you are dealing with actual production scenario, then the things which you have to execute, being the plant manager, production manager, are little bit different. They, instead of going by objectives like maximize or minimize, they go by goals. Okay. So here we'll be looking at goal programming formulation. In goal programming formulation, there are two things. One, we have to look at rigid constraints, like these two constraints we have considered because of the problem given, because of something given in this problem. These are considered as rigid constraints which must be satisfied. Okay. Rigid constraints which must be satisfied, or they are to be treated at first priority. Okay. Now, something which is given to you in this problem, in addition to this detail initially given to you in the problem, these are some details. These are normally considered as goal. Okay, in the sequence they are written, they are prioritized. This is first priority goal, that the profit is to be kept above 100, 800. It doesn't mean that it essentially has to be greater than 800. Sometimes it can be 700 also, 600 also, 900 also. Okay, that is simply a target given to you. Okay, and this second statement which is made, that is the second goal. If at all the situation wants you to order chemical 3, then its order must be limited. It should be less than equal to 8. It doesn't mean that you cannot order it more than 8. Okay, it may sometimes go beyond 8, but you have to reduce the possibility of that happening. Okay, but as far as the availability here given in this table is considered, it is considered to be 50 and 60. Okay, then finally the production is to be minimized, and it is to be kept to certain value like 8, but it doesn't mean that it has to be less than equal to 800. It may sometimes go beyond 8. Some flexibility has to be there when you are executing your production, being a production manager or production supervisor. Okay, so these are called as goals, these are called as targets, and these are called as rigid constraints. Okay, so now how the formulation is done in case of goal programming, that is interesting to see. Okay, goal programming formulation, here I write. So very first, I will not be writing the objective function. I will be writing it at the end, because it is possible for me to write the objective function only at the end, after I complete my consideration on the rigid constraints and the goals. Okay. So first of all, I know these are my rigid constraints. So how I have to write them? Okay, all the constraints to be written here are in equality type of form. Okay, now I know that 3x1 plus 4x2 is less than equal to 50. Okay, so what may happen, that this may sometimes be lesser than 50 or sometimes be greater than 50, which I want to avoid. Okay, so if for greater than, I will be writing, I take two types of variable. Here I will be calling one variable as di minus as underachievement. All right, and di plus, I'll be calling it as overachievement. All right, with this we'll be handling all the constraints. Okay, once you understand in what way these are to be used, okay, and how they are to be translated to objective function, your goal programming formulation is done. All right, so let's see how do I handle, how do I convert this rigid constraint into goal programming constraints. Okay, so I'll be writing 3x1 plus 4x2. Now, this value can be less than 50. Okay, so this side can be less than 50. So what I'll be doing, by whatever extent there was underachievement of this side by 50, it is something like slack variable only. Okay, so that thing I'll be adding d1 minus. Okay, This was underachievement. It is like slack variable only. Di minus. Okay, there the value could go beyond 50 also. Okay, suppose say this sum is 40, then the value of underachievement will be 10, because I want the target for chemical 1 availability for chemical 1 is 50, and what this is taking is 40. So underachievement will be up 10. Okay, but if this sums to 60, then overachievement will be 10 again. And for bringing the equivalent between these two sides, left hand side and right hand side, I'll have to subtract overachievement and I'll have to add underachievement. Only one of these two things will be happening. Sometimes there will be underachievement, sometimes there will be overachievement. Both the things cannot happen simultaneously. So underachievement I'll be adding and overachievement I'll be subtracting. So D1 plus stands for overachievement. This is equal to 50. Okay. All right. Now coming on to, once you have understood this, the rest of the constraint, understanding rest of the constraint won't be much difficult. Now let's go on to this. This is about second chemical. All right. Second chemical is um, 5x1 plus 6x2 is the requirement of second chemical. 5x1 plus 6x2. All right, 6x2. Now, this side could be 50, for example, or 40. 40 means something which is underachieved has to be added to you, added to this left hand side, like we added d1 minus, will be adding here d2 minus. D2 minus again is similar to what we had been having the slack variable in case of LPP. D2 minus, this is underachievement value. By whatever amount, the left hand side is smaller than the right hand side. Okay, but in case the left hand side happens to be greater than the right hand side, then there will be something which will be subtracted, that is called as D2 plus, that is overachievement of left hand side, that is to be subtracted. This is 60. Okay, but first of all, we'll become completing all the constraint writing, and then we will be writing the objective function. But we have to segregate between two. This is rigid constraint, because that was the information given to you in the problem. Now coming on to the first statement, okay, Mm, we will have to go by this sequence now. Profit is to be kept above rupees 800. All right. So what is profit now? Profit is 70x1 plus 80x2. 70x1 plus 80x2 is the profit. Okay. Now we have something to be written on the right hand side, that is 800. Okay. Now, if this side is less than 800, then we will have to add something here, that is underachievement of the profit, that will be D3 minus. And if this side is more than, if this side is more than 800, then I will have to subtract the overachievement, D3 plus, right? So the first goal sort of thing I have taken care of. This is not that rigid as this were. Okay. So these rigid constraints I will be grouping in one. Okay. Then here I write rigid. Then quantity of item 3 to be ordered should be less than equal to 8. Okay. What is the quantity of 3 to be ordered? um, quantity of 3 required is 1. So x1 to be ordered means it is availability. Okay, so here what I'll be doing, x1 is the requirement. On the left hand side I know the availability is going to be 8. Okay, now if this quantity is less than 8, then for bringing the equality, what I will have to do, I'll have to add d4 minus, and if suppose say I ordered, if this becomes greater than equal to 8, then I will have to subtract d4 plus. Once again, I repeat that either of these two will exist. Both of them, either there will be underachievement or there will be overachievement. Both the things will not happen simultaneously. Now, total production is to be minimized and is to be limited to 8. So, what is total production? X1 plus X2 has to be equal to 8. Now total production can be less than 8. So for bringing the equality, I'll be adding d5 minus, and this can be greater than 8. For bringing the equality, I'll be subtracting d5 plus. Alright. Now how to write the objective function is an issue. Okay. So our objective function is written in a lexicographic way. Means it is to be written in the sequence the targets are to be achieved. Okay, the coefficient do not make much of the difference here. Only it is written. What matters here is the sequence. Now, and one more thing you have to remember: objective function will be of minimized type. Okay, we have been used to formulate or consider objective function of maximized type. Where here, because our first priority is 1, second priority is 2, third priority is 3, like that it goes. So higher priority are lesser priority for us. Okay, so our objective we will have to keep as minimize. Minimize means lower the value, better it is for us. Okay, so objective function which finally has to be written at the top, I'll be writing it at the bottom because it is possible for me to write the objective function once I write the constraint in this form or goals in this form. So minimize, it has to be minimize z equal to. Now, first priority is indicated by P1 coefficient. Now, under first priority will come all the constraints which are rigid type of constraint. Okay, and here the variables will never be x1 x2. Here the variables will come from underachievement or overachievement. Now you have to think what is to be minimized amongst these two. Okay, what is to be minimized for this constraint to never get violated. Okay, this should be minimized, this should be kept as low as possible. Okay, we do not want overachievement. Okay, this d1 plus is to be kept as low as possible, because if this has certain value, it will mean that this is greater than 50, which I never want. So this is to be kept at minimum. Also this is to be kept at minimum. D1 plus, okay, plus D2 plus. I am combining them because they are all the part of rigid constraint. Okay, D2 plus. All right. And there is no more rigid constraint. Once again, I repeat, okay, in the objective function, there will be one coefficient which will be indicating you the priority at which that goal is to be achieved. So this is first priority goal. It is indicated by P1. P1 doesn't have any other significance other than being a sequence number. This is first priority goal. And what is to be minimized at first priority? This too. Okay. We cannot minimize this. Okay. Because we have the limit of 50 and 60, as much these values will be, better it will be for us, but it won't be better if these values are, there is a value to this. We don't want the value to this. Okay. Now coming on to this, only this is the skill. What among these two variables will be there in the objective function? Now your second priority goal is indicated by P2. Now in P2, you know that you need profit of 800. Okay, so you don't need the profit of less than 800. Okay, so less than 800 will be indicated by some value to D3 minus. Okay, you want to minimize, you want to, um, just a minute. Here one now this is a point where you will be understanding the things. Now which of these two will have to be minimized? Okay, you don't want this profit to be less than 800. Okay, you want to overachieve the profit. Okay, you want to overachieve means you want to minimize D3 minus. You don't want to minimize D3 plus. Okay, so you will be minimizing this quantity. It should be as minimum as possible. It should be zero. Okay, and this may be as much as possible, but we are not considering about as much as possible because our objective is of minimize. Okay, so we want to keep D3 minus as D3 minus minimum. We are concerned about uh, our goals. Even if it is reached to 800, that's fine for us. Okay, if it is exceeded more than 800, that is good for us, but we are not insisting for that. We are insisting for minimizing D3 minus here. All right, then coming on to this constraint. Okay, x1, that is the chemical 3. This constraint is about chemical 3. Okay, it should be ordered less than 8. Its availability is to be kept less than 8. Okay, but it can sometimes be it can sometimes go more than 8 as well. Okay, so now here first thing, you know what you have to write. P3 is the priority, third priority goal. Okay. Now, what among these two should come to multiply to P3 is to be decided. All right. Now, D4. If you want to keep this as much less as possible, as less as possible to A, okay, this will be more. Okay, this will be more, and we want that. We want this to be more, but we want this should never go more than 8. We want to minimize D4 plus. Okay, we want to minimize D4 plus. You find out your own mechanism of finding which variable out of these two will come to multiply, and it's very simple, but sometimes it will stuck you up to think of whether it is this or this. Here it is D4 plus because you want to minimize this because of the condition given that you don't want to exceed the ordered quantity to more than 8. So this is to be minimized. Overachievement is to be minimized. Okay, and the production is also to be minimized. Right, production also to be minimized means you want to minimize overachievement of the production. That will come as the fifth objective. plus fourth priority objective, and what among these two will come to multiply? You want to minimize D5 plus. You want to minimize overachievement P4 D5 plus. Just a minute. Um, P4 D5 plus, right? This is the formulation. Once the formulation is done, solving this by simplex method won't be difficult. But this is not the problem which I'll be solving by simplex method. I'll be solving another problem by simplex method. Simplex method, you know. So formulation becomes very important, and you know by now the unusualness of the formulation. Now we'll be taking another problem and we'll be formulating that problem as a goal programming problem. That problem will not be formulating as LP. Okay, will be directly entering into goal programming, and possibly that will be the problem which I'll be extending to get the solution up by simplex method, right? So let us take another problem. Now, here is the second problem. Uh, there are two products A and B to be assembled. Details are here A and B products are given. Time for assembling in hours is for A it is 4 hours and for B 3 hours. Available time is 90 hours. Right? Profit per unit is rupees 7 for A and rupees 8 for B, and demand is 30 units for particular period of A, and demand of B is 40 units for particular period. Now, whatever information given in this area, you may consider to be contributing to rigid constraints. All right, and the goals are: your first goal is demands have to be met. Okay, that anyway we were considering them to be in the rigid constraint part. These are the demands and those have to be met, right? Regular time is 90 hours because it is in this area we were considering them under rigid constraint. Okay, so first two as it is we were considering, all right, then this becomes a goal, real goal, right? Minimize overtime, avoid exceeding 150 hours. Okay, now you may believe that if you want to produce item A and item B, for example, it requires 4 hours for assembling A and 3 hours for assembling B. Now the demand is this one, 30 and 40. So by looking at the problem, you know that total time required for completing the order is 4 into 30, that is 120, and 3 into 40, that is 120 again. So 240 hours are required and your regular time is 90 hours. So it's not feasible to complete the order by doing the operation in regular working hours. You will have to have overtime production. So it is given in the problem that minimize the overtime, avoid exceeding 150. Now here when you see here 150 plus 98 is 240, but it's not necessary that this will be 150 always. It may be given, or the production planner may consider this as 100 hour, 200 hour. Okay, but you have to minimize the overtime operation of the plant. That is the goal, and maximize the profit. Try having it more than 200. Okay, we are trying to maximize, but mm, we have kept the goal up 200. Here we have kept the goal up 150. Now let us see how we formulate. First of all, we will have to take the regular variables late x1 and x2, x1 and x2 be be the units produced of A and B, units produced uh, of A and B in regular time. RT, I'll call it as RT, regular time, right? Then Y1 and Y2, different students, different these formulators will formulate it in different way. Okay, it's possible to formulate the problem, particularly goal programming problem, by having different considerations, right? Y1 and Y2, there might be little bit variation, not too much. Y1 and Y2, B units produced of A and B in overtime hours. So some products will get produced in regular hours. Regular hours are charged at normal rate. Overtime hours are charged at double rate, or might be 1.5 times the regular hour rate. Okay. So it costs more to the company if the production is taken in overtime hours. So I1 and I2 are the items, units which are produced in overtime hours, right? And now with this one, we will start writing the constraint directly, right? Very first is uh, demand, because that is given at the first level. Demands have to be met even if not given, okay, because all these three constraints will be at same priority, that is demand constraint and the availability constraint, they are going to be at same priority, right? So their sequence doesn't make much of a difference, right? So I am writing the demand constraint first. Demand for product A is 30. That means normally X1. What is the demand for product A? Now how I am going to get product A? Product A I am going to get by regular hours production and overtime hours production. So I can write X1 plus Y1 is the regular time production. Okay, X1 is regular time production, Y1 is overtime production, and this is the production of item A, and the demand for that is 30. 30 I am going to write this side, right? Now your demand, your production may be underachieved or maybe overachieved. Demand is 30. Right, so you may fall short of 30, and if you fall short of, you have to add d1 minus underachievement. And if you increase more than 30, because there is a possibility of increasing also, we are giving that flexibility, okay, that is to be subtracted to keep the balance. D1 plus this is equal to, either of this thing will occur. If this happens to be 40, then something will have to be subtracted. All right. Then likewise, second constant also can be very easily written. That is about the demand for B. Right. This is for A. Demand of A. And another is what? X2 plus Y2. X2 is the regular time production of B and Y2 is the overtime production of B. Okay, and that has to be equated to 40. Now there could be underachievement or overachievement like has been for product A. So here I am writing plus D2 minus and minus D2 plus. This is for B. Alright. Now, one more constraint is coming out. Regular time is 90 hours, right? Regular time. Now, how much is the required time for assembling A? It requires 4 hours, and we are producing. We are having um, X1 units to be produced in regular hours. Okay, so 4 into X1. Okay, plus 3 into X2. This is the regular hour production of item B. Time required for regular hour production. Okay, 3 hours are required for assembling 1 unit of B, and we're assembling X2 units. We are assembling X2 units in that time. All right. So 4x1 plus 3x2, this has to be equal to 90. Again there will be overachievement or underachievement of the time, right? So this time may be less than 80, less than 90, and if that is, I will have to add underachievement time, that is d3 minus, and if this is more than 90, then I'll have to subtract d3 plus. This is regular time constraint. All right. Then coming on to minimize overtime, avoid exceeding 150 hours. Now, what is overtime here? Okay, overtime, this is underachievement of the time. Okay, this might be 80 hours. So you are still having 10 hours, that's fine. But if this is 90 hours, then whatever you will be getting the value of this. If this is 90, then for balance, sorry, if this is 120, 4x1 plus 3x2 happen to be 120. Then for balancing the equation, this has to be 30. And that 30 is nothing but the overtime. Okay, so D3 plus is nothing but the overtime. Okay, and I want to limit that overtime to 150 hours. So D3 plus is the overtime. Okay, on the right hand side, I have 150 hours limit. Okay, so D3 plus could be less than 150, or it could be greater than 150. By what extent? If it is less than 150, then it will be less by D4 minus extent, underachievement of overtime. And if it is greater than 150, then it will be greater by D4 plus extent. Okay, here I have identified this as overtime D3 plus, and that I have utilized here to write the goal for overtime. D3 plus is overtime. Okay, overtime. So this is a goal on overtime. Okay, and one last goal I have to write: maximize the profit. Try having it more than 200. Okay, now how do I write the profit? How many units I am producing? I am producing x1 plus y1. Sorry, profit is going to be 7 into how many units of A I am producing? 7 into x1 plus y1 plus 8 into what? 8 into x2 plus y2. Mm, this is the profit. Okay. This is to be equal to, and I have to target the profit to 200. Okay, actually that way the profits on regular items produced, items produced in regular hours and produced in the overtime hours are going to be different, because overtime hours production is going to be charged highly, and regular time production, the cost of production is going to be less. But it is the profit figures I'm considering, they are given as an average production, average profit, considering irrespective of whether the product is produced in overtime or regular time. So here I am taking it this way, and this is to be equal to 200. Now there could be overachievement and there could be underachievement. If this value is less than this, then I will have to add, that is D4 minus, sorry, D5 minus minus d5 plus. All in all, by now you must have understood the pattern. Now, what is more important here is making the choice of one of these two to have the place in the objective function. Objective function is going to be minimize z equal to, all right. Now first priority, these are the essential constraints. These three are the constraints which are essential, rigid constraints, so they must be placed at first priority p1. Okay, so what among these two is to be minimized, right? See, um, I have to have mm, the demand is 30. Demand is 13 means I should be in position to supply more. All right. So demand is 40. Sorry, demand for product A is 30. 30 means it will be better if I don't fall short of this 30. I want to minimize D1 minus. Okay, it should be as close to 0 as possible. Okay, so D1 minus I will be minimizing. I want D1 plus as much as possible. Okay, so I want to minimize D1 minus. So similarly, demand of B is also to be satisfied. It has to be more than 40. So I want D2 plus as much as possible. That means D2 minus as less as possible. Okay. So plus D2 minus. Now regular working hours are 90. Okay. So I will be needing the D3 minus should be as more means D3 minus, I will be needing that this should be as less as possible. D3 plus should be as minimum as possible. Okay, because more this will be talking about more of the regular time. Okay, this will be if this is more, then this will also be more. I want to keep it less. D3 plus I want to keep it less, as less as possible. Okay, so I will have a D3 plus here. Okay, because I want to keep it as less as possible. Yeah, otherwise there is a tendency of working less in regular hours and working more in overtime hours. Okay, so D3 plus, if I keep it as less as possible, that will ensure more working in regular hours. Okay, so these three are coming at one level. They are to be achieved at first priority. Now let us go on to the next. Next goal is overtime, right? Now, over time, I want to limit to 150. It may exceed 150, but I want to keep that exceeding part as less as possible. So, P2. Now, which of these two I'll be keeping lower? Okay. So, I will be keeping this part, D4 plus. Okay. D4 plus, because keeping this overtime lesser, limiting it to 150 will want me to have this as D4 plus minimum. Okay, D4 plus minimum. I want to minimize D4 plus. All right. Then lastly, I want to keep my profits greater than 200. So that is coming at third priority, P3. Okay, here only three goals are given. Sometimes there are four, five. All have to be considered in the sequence manner, lexicographic manner, as P1, P2, P3, P4, like that. P3. Now, what will come to multiply to P3? Whether it will be D5 minus or D5 plus. What do you want to minimize? Okay, D5 plus is better for you. More its value, it will be indicative of higher profit. Okay, so you want to minimize other part, that is D5 minus. Okay, so this is how the goal programming problems are to be formulated. It won't contain any of the regular variables like x1, y1, x2, y2. It doesn't contain any of such variables. All right. So now we'll be solving this problem by simplex method. Okay. So uh, mm, just put this in the simplex table. All right.